Hello everyone, myself Mukesh Kumar Tiwari from LPM Public School. Dear student, as you all know that the things is not very common for us. That means the we have to return on our previous platform. Means now from today we have to consider our things or our topics through the videos or online medium. Reason is that the corona cases are very in peak. You also know that you are very precious for us and for your parents also. So from all these facts, we have to start our topics, our subjects from videos, because your study cannot be stopped. So let's start. We have to talk about the chapter that is the coordination compound. As you all know that in the classroom we have to talk about, or means physical classes, we already talked about for the various things related to the coordination compounds, like their nomenclature, how to write their name, and how to make their formulas from their given name. So these all things are the some also important terminology we also consider. So now today we will discuss about the next topic of the coordination compound, which is the isomerism. This isomerism is also important in the coordination compound, because most of the question are arises from this portion, and in your board this is very important topic. Or so let's we are going to start the isomerism in complex compound or coordination compound. Isomerism in coordination compound. Isomerism in coordination compound. As you all know that isomerism means two or more compounds having the same molecular formula but different structural formula are said to be isomer, and the phenomenon is known as isomerism. Clear? And you are earlier know about the isomerism. The isomerism are broadly classified into two parts, that is the structural and the stereoisomerism. Clear? So in the same way here we also discuss about that the isomerism in coordination compound is also are broadly classified in two parts, that is the structural isomerism and the stereoisomerism. Clear? Isomerism in coordination compound are broadly classified into two parts. The first is the structural isomerism. Structural isomerism. And the second one is the stereoisomerism. Stereoisomerism. So the structural isomerism is also are of four types. This structural isomerism, in case of coordination compound, it is are of four types. First one is the hydrate isomerism. Hydrate isomerism. Second one is the linkage isomerism. Linkage Isomerism. Next one is the ionization. Isomerism. Ionization. Isomerism. The last one is the coordination. Coordination. Isomerism. So the structural isomerism are of four types: hydrate, linkage, ionization, and coordination. Clear? And the stereoisomerism are two types. The first one is the geometrical isomerism. Geometrical isomerism. The second one is the optical isomerism. Optical isomerism. Geometrical isomerism and optical isomerism. This geometrical isomerism is also known as cis-trans isomerism. Cis-trans isomerism. So once again, look at the various type of isomerism which are found in case of the coordination compound are listed here. Structural and the stereo. Structural are of four types: hydrate, linkage, ionization, and coordination. And the stereo are of two types: geometrical and optical. Geometrical is also known as cis-trans isomerism. Clear? Now here we will talk about for these all type of isomerism in one by one. Clear? So first of all we discuss about the structural isomerism, that means the hydrate isomerism. What is the hydrate isomerism or their explanation and their example? So let's discuss about the hydrate isomerism. We are going to discuss about the hydrate isomerism. Hydrate isomerism. The word hydrate is related with the water molecules. Means this type of isomerism is generally shown by that coordination compound or complex compound in which the water molecule are present as a ligand. Clear? So how we explain the hydrate isomerism? So first of all we have to follow this is an example of coordination compound in which we have to discuss about the hydrate isomerism. So first of all we have to discuss about the what will be the IUPAC name of this compound. As you all know that the name are very easy to write. The number of water molecule is 6. So we use here word hexa, and water, for water we use aqua, hexa aqua, and the central metal ion is the chromium. So hexa aqua chromium third chloride. Hexa aqua chromium third chloride is the name of this compound, and we have to talk about the hydrate isomerism in the case of this compound. So let's how we find different hydrate isomer. So look at here, the number of water molecule in this case here 6. So one by one we replace the water molecule with the chlorine atom. Clear? Like this is the first case, and now the second case is the when we remove here one water molecule, then this will becomes as CrS2O whole 5, and one of the chlorine is inside the sphere and the H2O will be outside. Clear? So this one is and this one is known as the hydrate isomer of each other. Clear? One again, one of the chlorine molecule will also enter into the sphere inside the coordination sphere, and one of the water molecule will also remove. Clear? So this one is the next isomer of this compound. Clear? So these all three compounds are considered as hydrate isomer of each other. Clear? This all compound considered as hydrates isomer of each other, and this phenomenon is known as hydrate isomerism. Clear? So when we talk about for the name of this compound, so how will you write the name? Here penta aqua chlorido chromium third chloride monohydrate. Chromium third chloride and then after monohydrate. Clear? Similarly here tetra aqua dichlorido chromium third chloride dihydride. Clear? So this is the example for the hydrate isomer and the hydrate isomerism. Clear? Now I will talk about for the next one, that is the linkage isomerism. Clear? I think it is clear to all of you what is the hydrate isomer. So you have to keep one thing in your mind. Suppose the two isomer are given to you, and the question will be asked that tell me which type of isomerism is shown by these compounds. Clear? So first of all you will check the number of water molecule inside the sphere and outside the sphere, and in this way you can easily predict the type of isomerism. Understand? Now I will talk about for the next type of isomerism, which is known as linkage isomerism. So come on. So today we now discuss about the linkage isomerism. Also, the second thing or second type of the linkage isomerism. Linkage isomerism. So first question is that which type of compound are generally shown this isomerism? Clear? So one of the important point you should have to keep in your mind, that is the linkage isomerism is generally shown by that compounds. Once again, the linkage isomerism is shown by that complex compound or coordination compound which contain ambidentate ligand. Clear? Which contain ambidentate ligand. So, what is the ambidentate ligand? You know very well. Clear? The ligand which contain the two donor atom, but during the formation of the complexes, it use only one of the donor atom. Understand? So, the linkage isomerism is generally shown by that complex compound which contain ambidentate ligand. Clear? So, I just here one of the example you can see here CONO2 and NH3 whole 5 and Cl2. Clear? So what will be the name of this compound? First of all, we will write the IUPAC name of this compound. So the name is pentaamine nitrite 2, because the negative ligand is nitrite. Clear? Ion. So nitrite 2 N. Clear? Why this N is used? Because in nitrite 2 there are two donor atoms are present, and this nitrite ion is an example of ambidentate ligand. Clear? So in the case of NO2, the donor atom is nitrogen. So pentaamine nitrite 2 N cobalt third chloride. Clear? So this is the name of this compound, but here we are not talking about for the name of the compound, we are talking about for the linkage isomerism which is shown by this compound. So this compound can also be written as COONO. Clear? ONO NH3 whole 5 Cl2. Clear? So once again we will write the name of the compound pentaamine nitrite 2 O. The name is will be as common as, but there is a slight difference in the name. Here nitrite 2 N is given, but here nitrite 2 O will be given, because in this case the donor atom is nitrogen and in this case the donor atom is oxygen. So pentaamine nitrite 2 O cobalt third chloride. So this is the name, IUPAC name of this compound, and if these two compounds are given to you and the question is asked that which type of isomerism is shown by these compounds, so you will say that this compound or these compounds are showing linkage isomerism. Understand everyone? Now once again we talk about for the another example for the linkage isomerism. So come on, what is the next example for the linkage isomerism? Suppose a compound are given like this K4 FeCN whole 4 SCN whole twice. Clear? This is a compound. This is a, suppose you can also write here OH whole 4. Clear? This is a compound are given to you, and first of all you will write the name of this compound. So the first one is the potassium. potassium. Clear? Here tetrahydroxide and here thiocyanate. So we use the name of this compound potassium tetrahydroxide, thiocyanate. This is the thiocyanate ion and this is also the ambidexter ligand. Potassium tetrahydroxide thiocyanate 2S, ferrate second. So this is the name of this compound. Clear? Once again, potassium tetrahydroxide dithiocyanato S ferrate second. So why the word used as S here? Because in this case the donor atom is sulfur. Clear? And this compound or the linkage isomer of this compound can also be written like this: FeOH whole 4 NCS whole twice. This is the linkage isomer of each other. Clear? So what will be the name here? Potassium tetrahydroxide diisothiocyanate and ferrate second. So this is the another example for the linkage isomer. So hopefully these two structural isomerism, that means the hydrate isomerism and the linkage isomerism, are clear to all of you. Clear? Now the next isomerism or the another type of isomerism I will talk about in my next video. Thanks a lot.